So I will move ahead. So thank you for inviting me to talk about this. It's a privilege to talk after Professor and me being a part of Team Shunya, and this is kind of somewhat related to my PhD topic as well. So the topic we will be focusing is beam-based automated compliance checking, and that in the context of construction 4.2. So the flow of the presentation will be as follows. So we will start with what is construction 4.0, what are their key components. Then we look into beam-based automated compliance checking, what I am talking about it. So for that, we should know what is BIM, different approaches of compliance checking, semantic enrichment, application of MLs in compliance, and finally, we will go to the limitations and I will conclude. So let us start with what is construction 4.0. So it is a term that was coined by German federal government in the year of 2016. Also, it's an adaptation of the idea from manufacturing industry known as Industry 4.0. Now, construction industry itself governs to almost 13% of the global GDP, and 7% of the world's working age population work in construction. Now, you may start thinking, why do you need to adopt from manufacturing? If I look into the average value added by employees per hour, so for the global economy, it's around $37 per hour, whereas for construction sector economy, it's around $25 per hour. Adding that together, the lagging productivity cost a year is almost 1.6 trillion. So construction obviously needs some improvement in its value chain, in its productivity, and also sustainability. Because if we compare between construction and manufacturing, we see the waste part is almost 57%. The value adding activities is 10% and supporting is 33%. Whereas in manufacturing, it's quite the contradictory. So that is why we start to focus and adapt something from manufacturing. This manufacturing revolution went in four waves. So it started with the first industrial revolution or industry 1 with steam powered mechanical production. Then with the electrical powered mass production, it came the industry 2.0. Then industry 3.0, what changed in the 1970s when it comes assembly line, automation, computers and electronics. Finally, today we are in the generation of industry 4.0, where we talk about cyber physical systems, Internet of Things or network, digital technologies, where these equipments are connected among each other, seamless data transfer and all those things. However, now it's already been working in Japan. They are thinking about industry 5.0, where it's more on a human-centric design than machine-centric design. But where are we from a construction industry? We are not totally even in construction 4.0. So why does construction industry lagging behind? Because we think that construction industry is a highly fragmented industry. If we look into a project life cycle, these are the different project life cycles of a construction. Now, after every phase, you can have a stop. Say in design, before after design phase, you can stop it. After construction phase, you can stop it and wait till it's get occupied by people. So every phase there can be a discontinuation. Similarly, there can be different stakeholders in your project like owner, designer, engineer, contractor. All of them have a different motive. They have a different target to achieve. So the communication and integration between the stakeholders become very difficult. Finally, there comes the longitudinal fragment. So we always tell that construction projects are unique. It cannot imitate manufacturing because every project have a unique design and it has its own timeline. So if we cannot replicate between project, it becomes very difficult. But is it so? Is it there no pattern uh, available? So that is what we're going to talk about. For that, let us start with when we are talking about construction 4.0, what are their key components? So we divide it, if this is the construction world view, we divide it into two parts. One is the physical world, another is the digital world. So in the physical world, it's when the human interacts with machines, and in the digital world, when the data is transferred through the digital tools layer to the data layer, and finally we have a central data management layer. Now, what important to understand is the flow of information in project lifecycle. So let us divide the project lifecycle here in four phases: design and documentation, construction and execution, operation maintenance, and renovation or demolition. as we discussed, we have a physical layer and we have a central data layer that is held on. Now, let us look into the interaction of it. So at the design documentation phase, we are going for some 3D models. We can do some simulations. We can do some energy analysis that will help us optimize our design. And here we can start thinking about something of generative design. So looking at the designer's previous designs, what are the patterns of its design, the system can start predicting what the design should be, and that could aid the designer in its decision making. So from here, we start looking at the influence of artificial intelligence and machine learning uh, in construction. In the reverse way, when a design is complete, we can have this 3D model going for our permits and contracts. We can use and analyze on this 3D model and get our permits ready. But now we are not doing it. We will discuss more on this later. Moving on to the next phase, in construction or execution phase, we can have a nth dimension building information model, where we say that this 3D model gets integrated with sustainability, your cost, time. There is cloud-based project management. And in the field, we have prefabrication, workers with wearable sensors, robotics, 3D printing, and all of them is kind of getting the data from a virtual reality or a augmented reality or a augmented world, and the data is transferred. Now at the site, when you have workers wearing sensors, that sensor is giving me data and helping me finding their safety, and those are through some lidar or RFID. Then there can be unmanned aerial vehicles or drones that see at the site what is the actual progress of the site. You can sit in your head office, you can compare the results with your plan versus actual. So that helps us developing the as-built beam and what's actually happening in the site, and that makes make the process much faster. Again, we see a footprint of artificial intelligence and machine learning in these two parts. Coming to the operation maintenance first phase, once your construction is complete, now generally we have the building there. Now we want to see what are the services doing, if there is any collapse, if there is people is uncomfortable, how my machines are working. If there are sensors in them and they can gather the data, they gather what is the comfort level and all those stuff that we work on. So now that will lead us kind of towards a digital twin. So where we say this model we were working on, 3D model, is now having all the data of the real life. So it's a real life virtual replica, and rather it have more data than in our physical world we can see. So it helps us understand when it can be changed, when it should be replaced, and we are going towards something of a predictive maintenance than reactive maintenance. Finally, and obviously, as we get the data, it goes back. We have the big data, then we do some big data analysis, and we take our decision. So it's a both-way communication. Finally, in the renovation and demolition phase, we say we have an asset or a previous heritage building. Now that needs to be renovated, and we want to see its structural integrity. So for that, we have to get the data. So we do something like we want to get the GIS, we get the lidar to get image or some point cloud data that we say. So it generates scans and generates small points, and from that we convert it to a BIM. Here also we can see the footprint increasing. Similarly, when there is a demolition, here suppose we want a circular economy where we want to use this demolition waste and recycle it. So there can be, if there is some IoT or there is some chips microprocessor, we can differentiate the elements, or image processing is already there to differentiate between the wastes, and it can identify the waste, and it can place the waste in different segments, like which kind of waste it needs which kind of recycling, and there are different methods of it. So a construction waste can have different things altogether. To segregate them, we need this kind of technologies again. So we see two presence in the whole construction cycle. So one is the presence of BIM, and another is the presence of artificial intelligence throughout the life cycle of the project. In the execution phase, we see some of them already in place and being worked on. What is not present totally is that in the Operation maintenance phase, we actually working on the physical work. Digital twin is also a concept we should work on. And then in this stage, we are working on 3D model, but finally we are transferring data in 2D. Now that have many problems. So can we help it in permit and contract in the design phase? Let us look into it. And that brings us to the next section. So now I will go more in the depth of BIM-based automated compliance checking, as I said, after the design phase. So let's start with what is BIM, or if I look at the BIM functionalities or BIM life cycle. So it can start with simple conceptual design where we do some shadow analysis, look at stuff. We can have a predictive analysis of building performance, like you can have your heating temperature, sun analysis, okay, sun path analysis, comfort analysis, and it helps in your rapid design alternatives. Similarly, when at construction, we can integrate the time and cost with it. We get construction 4D and 5D, and again, it's helping us getting decisions. In the detailed design stage, you can integrate your structural design and more information with model integration. There can be documentations with automated drawings. And finally, when you have a complete model that have all the data, when you have a properly rebar modeled, you can simply send that data to a CNC machine and ready-made steel can be made, and it makes the process much faster. So that is direct information transfer. Now, apart from that, there can be construction logistics like safety, operation maintenance, digital twin or facilities management, renovation, demolition, we have already discussed. So in the upper part, you see it's all about visualization. And in the next part, it's more on electronic communication or data transfer. One thing is still missing in this image that I can say is collaborative coordination. So as there are multiple stakeholders in construction, you can say the integration between them is what is most important. So clash detections, there can be cases in the site that is non-reversible where there is a material waste. So to reduce the waste, why not simulate that chances, what are the problems, okay, what design changes is required at the clash detection stage, identify them earlier and go to the site. So that kind of reduce your waste as well. Now after BIM, I talked about automated compliance checking or permit compliance. So why do you need that? So as per researchers, generally in many countries, the local authorities are doing that manually, that checking. And now with the increase in number of different codes and in the complexity of the code, it is becoming very difficult because all this process is error prone, and also it is time consuming or causes delay in the project. And with time, we have a new technology or a data structure that is coming, that's industry foundation class, that made the BIM environment collaborative information exchange easier. So in that way, we are going towards this because the technology now supports us. So let us look at a current stage of pre-construction permits. Suppose these are the phases that we were talking about. Now, between your design phase and construction phase comes the pre-construction permits. Now, in India, we need more than 75 different permits. Can you imagine about the potential impact of the time? So let us take an example. We have an architect who creates a design, then send his 2D drawings to the municipality for checking. Now, somehow it goes around 7-8 tables for different permits and it gets rejected. It comes back to the architect. She iterates over all the drawings because they are 2D drawings. They don't have any connection among each other. She works on it. It takes time. She resends it to the municipality. Well, this time it may be get accepted. So what can be the total time consumption? That is why it's more required to move towards automatic total compliance. Now, when we look at BIM, the industry actually is using BIM to its minuscule capability, or it's mainly used at the design phase, where we say that generative design to some extent is used for parametric design. But beyond that stage or design stage, the information is transferred to 2D drawings. So that 2D drawing terminates all collaborative and integrating benefits of BIM. There can be different compliance checking approaches. And they need it because of different type of data can be there. Data can be pre-processed, there can be missing data. How do I handle all those things? So for that, there can be different approaches. One can be plugin application. Second can be an object-oriented approach, that is BIM currently at this stage. We can have a logical approach, or we can have the clauses, and natural language processing can look at those clauses and find out what are some numerical clauses where the rule-based application can be directly done. And there can be performance-based clauses where you probably need machine learning to look at it, or it might need human interventions in those clauses. They cannot be directly automated. And finally comes ontological approach, where we talk about semantic web technologies. And this is the most complex process, where it takes into consideration all the relations of this object-oriented approach. So as we move from left to right, this process becomes more and more complex. However, the making of this is complex, but the user feels more and more comfort towards the right. Now, let's classify the complexity of rules. So there can be 4 classes. I'm skipping 1 and 2 because they're quite simple to understand. So class 3, let's say it requires an extended data structure. Now I'm taking example of an international code where it says that the distance between electrical fire detectors are different in case of corridor, in case of other rooms, it's having different dimensions. So when you are going to analyze this or going for automated compliance checking, you will first have to understand what are the different rooms. Now, to understand that, if there is no pre-processed data that which is a corridor, that becomes a problem. So in this kind of things, we can go for a knowledge-based solution. So a knowledge-based solution means you look at the previous data, and now the system itself, rather than checking what the designer have created, he can look at the previous data or the pattern of design of the user, and he can predict these locations, and it can help in the decision making of the user, and create a layout such that it doesn't fail, and it can confirm it from the user itself. So that helps us towards decision making. Now, talking about decision making, we come to artificial intelligence. So by definition, artificial intelligence says that it is the automation of activities that we associate with human thinking, activities such as decision making, problem solving, and learning. Now, we talked about BIM doing many things, going throughout its life cycle. It seems very intelligent thing to work with. But is it really intelligent? So that's a doubt. Let's take a couple of examples. Let's say there is a staircase or a balcony railing that has been missing. The designer have forget to put that. Now there can be cases where it's required and it is not required, but it will fail when it goes for compliance checking. So before going that, can the system, help the user to identify that this can be a potential problem when you go for compliance checking? That saves a lot of time. That saves the data to go, like the model to go to municipality, come back, and all those stuff. Similarly, the relationship between column and beams. Beam understand, okay, when I move a column, the beam should increase in length. But do you understand if I remove the column to 50 meters, it's not even possible? It doesn't. So it understands to some extent, but after that, it doesn't process it. So we can say it's an ignorant process. Can we make it aware? And that is where we are looking into, is it possible to look at all the collective experience of all the previous data of projects we have, and does it help us make a move towards semantic enrichment, and can it make BIM more intelligent? And that is the way we are looking forward. There can be different approaches of AI. One can be a behavioral aspect and one can be a thought process. So the behavioral aspect, it mainly deals with rule-based approach, and the second part, it deals with label data or knowledge base. So in this case, we talk about it helps in the decision making, whereas the first case, we see that it looks into the relation and looks into the rules. So we can say the first part is deductive in nature, the second is inductive in nature. The problem with rule base is that if there is not proper pre-processed data available, or there is high complexity, it can fail at times. However, in this, the second case, it ideally generate result, but it not be right at the first time, okay? Because it's predicting and the result increases as the data set increases in volume. So the first case have a higher accuracy rate, and the second case, as probabilistic, it has a lower accuracy rate than rule-based approach. So that's a problem. That brings us to semantic enrichment. In a BIM, there can be three kind of data. One is explicit data, something like floor to floor height, and building footprint. So those can be easily extracted, and that doesn't need any problem that doesn't make any problem in compliance checking. Then there can be missing data. Some data can be implicit, where it makes sense that your floor should have a material, but you cannot predict that data. Okay, so that is your design data, because that floor material is a decision of your architect, but you know that is required, but you cannot predict it what floor material should be, and that will change your design calculations as well. So that is where it comes, but there can be some missing data that can be supplemented. That is why where we look at the spectrum of hybrid approach. So there can be semantic enrichment and automated compliance checking. Now, there is two part. One is fully enriched pre-processed data, that is the semantic enrichment in the first phase. And then we are working fully rule-based methods to do automated compliance checking. So there is shouldn't be any problem. And the final can be partially enriched and partially rule-based. Inside that, we can have these different things. The current state is here. In this phase, we say that the semantic enrichment, okay, it can be fully rule based rather than manual. So if there is data missing, the system starts predicting it, and it can be partially enriched also. Okay, so here machine learning comes into picture. It predicts, it goes back to the designer, and it asks the designer whether it is right or wrong. So there comes the authority of it. But for the complex checking, when it comes out of the designer's hand, it goes to the municipality. It's still fully rule based. So there shouldn't be any problem. For the next case, we say that the next part becomes machine learning based. So here what happens is you give a model when everything is not pre-processed, okay, and unfinished data. So then can I predict, looking at the whole building, whether it will pass or fail in a particular thing? And then it becomes very difficult, because as professor have also discussed, so from left to right, we see that applicability increases. There can be cases, if there is not data, then also you can use it. There are benefits of it. So adaptability increases. But the problem uh, arises, it decreases in accuracy and liability. In the first phase, as we are checking it back from the designer, you can still say that designer had the liability or accountability of it. But in the second case, when it's going to municipality, and if it gets a wrong data or a comparison, if the design is wrongly passed, then who takes the accountability or liability of it? So this is still a gray area for this whole spectrum. Now, just overall, let me have a whole idea of how BIM-based development control rules as a automated compliance checking system works. So if we have a 3D model like IFC, it's been uploaded from architect. It looks at the missing data that requires for automated compliance checking. It uses hybrid approach. It mix and matches the rule-based and ML-based approach to find out what are the data that are required. And after that, we get the results of automated compliance checking. Here also we can use rule based on machine learning that in the spectrum I have shown you. After that, the data is updated in a GIS-based platform. So this is kind of going towards a digital twin finally. And once we have the digital twin with all the compliance data, all the codal data, so there we can do real-time operational analysis, failure mode and effect analysis, statistical model, all this calculation. Suppose there is a flood coming, and how to evacuate and which city portion to be evacuated, and all those stuff helps us in real-time operation management. Now, moving a bit out of my PhD topic as well. So there are different applications of ML in object classification in construction as well. So one of the example was I was giving. So this is, you see a point cloud data. So this is kind of an image of different points. From that, we have to make a 3D model for structural integrity or to add a new portion in the structure. So here what we can do is ML can apply in ML. We can try to look at the, rather than a modeler creating everything, going to sections, going to different drawings and understanding whether it is a beam, it's a column, what can be there inside a ceiling. Computer can look at it, look at the pattern of their shapes, and they can predict what should be there, whether it's a beam, column, and how it should be placed. So it eases the process. Similarly, in this case, you can have a building floor where there are 300 rooms, and then you have to identify the corridor, as I have mentioned earlier. So in this case, can I look into the pattern of these rooms? What equipments are there? Whether doors are swinging in or out, and can I predict this is a living room, this is a bathroom, this is a kitchen, and we can understand why it's inside it or outside it. We can calculate the FSI, and all those stuff becomes easy. Similarly, it's not only about uh, code compliance for a site, it can be safety compliance as well. So in this case, as you see, a computer vision is helping us understand whether the workers at site are wearing this personal protective equipments and they are working safely. And there can be RFID based solutions, as I have mentioned. So you have a virtual reality model where do we know that what are the potential risk at sites. A worker with wearable sensor, when he goes near to that and he doesn't have proper equipments, the safety manager from looking at its monitor or something, he can understand that this is going to be a problem, and this RFID based system can give a warning signal to the user, and these predictive safety measures help us save lives as well. But then again, as Professor have also discussed, there are many potential challenges in moving into this. So first is there is not much standardization of it. Only one code is there, that's ISO 9650, but mainly that's only one piece of the puzzle. Then if proper training is not given, the harmony will not be maintained. So you are saying we take many equipments, we improve the digitization, but if the labor force is getting removed, they will start revolting and the problem is there. So you have to train them as well. And again, there is high investment cost, high potential impact on the society as well of it. And also, as there are multiple stakeholders involved, so IPD is kind of inevitable. Without integrated project delivery, it's not possible. And it may require government initiative and aiding to adopt these technologies. Finally, there will be shortage of proper management skills or labors, because here you need more skilled labors than normal labor. So those kind of problems will be there. And finally, as I said earlier also, there can be 75 different approvals that are required in India, so that increases the complexity. So finally, in a nutshell, if I want to talk about the whole process, what I said is construction 4.0 is at its infancy, but it's quite an interesting area of research because it talks about interaction between the technologies and how to move forward. And then the study also shows in a project life cycle what can be the different tools that can get integrated. So it can help stakeholders, to understand which technology they can adopt faster and which is easy to adopt to move forward and reduce the time and improve the productivity. We looked at some beam-based development control rules in automated compliance checking, how that can help. And finally, especially in this kind of things, it's more better to have a hybrid approach than only ML-based approach because of this accountability and stuff. And with that, I would like to conclude and thanks.
Thank you so much, Ankan. That was a very detailed and informative presentation. I'm sure everyone in attendance did learn a lot of stuff from the presentation. I would also like to thank all of you who have attended this tech weekend, and I'm sure you all have had fun. If you have any questions or any reviews, please post it on the form that has been circulated in the chat. I would also like to mention Aditya Kumar, who is also an assistant events manager with me at Team Shunya. Ankush Pujari, who is the project lead at Team Shunya, and Utkarsh, who is also an assistant events manager, and Owais, who is a project mentor at Team Shunya. Thank you everyone for attending.